Hi, welcome to our last lesson in the fields topic, which is comparing electrical and gravitational fields. And we've been doing a little bit of that as we've gone through, but we're just going to get the points that you need for the specification. So the key similarities that you need to know: both have inverse square force laws that have many characteristics in common. For example, the use of field lines, the use of the concept of potential, and the idea of equipotential surfaces, etc. And that's taken directly from the specification, so that's exactly what they want you to know. Similarly, in terms of differences, they want you to know that masses always attract, but charges may attract or repel. Similarly, you also need to know that gravitational fields affect masses and electric fields affect charges. This, I've pinched out the textbook. Nice little comparison of Newton's law of gravitation and Coulomb's law. So for Newton's law, the force is felt by objects with mass, whereas in Coulomb's law, it's objects with charge. Newton's law, the force is proportional to that of the masses, to the size of the masses, whereas in Coulomb's law, the force is proportional to the size of the charges. Newton's law, the force is inversely proportional to the square of the separation of the masses. Coulomb's law, same but for charges. Gravitational field is around a mass, whereas an electric field is around a charge. There's only one type of mass, but there are two types of charge, positive and negative. Gravitational force is always attractive, whereas Coulomb's law says that electrostatic force is attractive or repulsive. Newton's law of gravitation, the constant proportionality is G, which is 6.67 by 10 to the minus 11 newtons per meter squared per kilogram squared. And they've said that K is the constant in Coulomb's law. Gravitational force is very weak unless one of the masses is very large. Electric force is actually very large, but most things have cancelled out charges anyway. Right, so this is Millikan's experiment, and Millikan did this experiment where he put a drop of oil in between two charged plates, and it was a charged drop of oil. He increased the potential difference between the two plates until the oil drop hovered, so the force from the electric field is equal to the force from the gravitational field. And what we can do, when we know that those two forces are equal, we can say that EQ is equal to GM. And we can use that to work out the specific charge on an electron. So specific charge is equal to charge over mass. So we take Q, we can rearrange that equation to Q over M, which gives us G over E. Now we don't know E directly, so if we were doing a calculation with this, we'd want to substitute out E for V times D. Okay, we did that in a previous lesson. Okay, that's all you need to know about comparing the two types of fields.